Hello and welcome to this video on adding and subtracting fractions. Now let's just say that we had a fifth and we wanted to add 2/5. Now if we do this graphically we might be able to see what we're going to do. So I usually draw these as pizzas. So a fifth, well if we divided this up into 5, we have a fifth of that, so 1 out of the 5 pieces. That's how we could represent a fifth of something. Now we're adding 2/5. So if I divide this into 5 again, because we got dividing into fifths, and we have 2 of those fifths, so I shade 2 of those. Now, can you see, if I have 1 of these fifths and I add 2 of these fifths, I'm going to have 3 of those fifths. So 1, 2, 3. It's a bit like saying, well, if I have 1 slice of pizza, which is a fifth of the pizza, and I take another 2 slices of pizza, in total I've taken 3 slices of pizza. So you can see we have 3 fifths. So you can see that if the denominators are the same, these are the same, then you can just add the numerators. And it would be wrong, by the way, to add the numerators and add this. You can't just do 1 plus 2 is 3 and 5 plus 5 is 10. You'd have 3/10 and that wouldn't be the right answer. You have to have the same denominator in order to be able to add the numerators like that. Now this one's a bit harder because the denominators aren't the same. So if we do this graphically again, well, we've got half a pizza and we're adding a quarter of a pizza like this. Now at the moment it's hard to see how we add these, but if we turn this half pizza into quarters, can you now see that we have 2 quarters of a pizza? So we have 2 quarters plus the quarter, and then because we have the same denominators, we can now add the numerators, so it would be 3 quarters. 2 quarters plus 1 quarter would give you 3 quarters. So what we effectively need to do is we need to find equivalent fractions to these such that we end up with the same denominators. Now in this case I could just change this fraction to make it over 4 to match this one, but it might be that you have to change both of them. So let's just take this example. We've got 2/3 plus a quarter. Now I need to have the same denominator. So we need to find equivalent fractions of each. And we need to multiply the top and bottom of this fraction by something, and the top and bottom of this fraction by something, so we end up with the same denominator. And basically we're looking for the lowest common multiple of 3 and 4. What do 3 and 4 both go into? We need a multiple of 3 and a multiple of 4 that's the same number. Well, they both go into 12. So we want them both over 12. Now we need to find an equivalent fraction to 2/3. So what do we do to the 3? Well, we multiplied it by 4. So we therefore need to multiply the top by 4 as well. So 2 times 4 is 8. So 2/3 is the same as 8/12. And then the quarter, I need to do the same. The 4, what did I multiply it by to get to the 12? I multiplied it by 3. So we need to also multiply the top by 3. Whatever you do to the bottom, you have to do the same to the top. 1 times 3 is 3. And at this point, I have the same denominators, so I can just add the numerators. 8 plus 3 is 11. So I have 11 over 12. What about the next one? We got 3/5 plus 5/6. Now to show you a slightly quicker way you could do this, what you could do is you could multiply the denominators, so multiply these. So 5 times 6 is 30, and then you cross multiply the numerators. Let me write that down. Cross multiply the numerators. And what that means is I do this times this plus this times this. Can you see that sort of cross? That's why it's called cross multiplying. So I do the 3 times the 6, which is 18, plus the 5 times the 5, which is 25. And then if I just simplify that, 18 plus 25 is equal to 43, and it's still over 30. That's a slightly quicker way you could do it. But beware, that sometimes doesn't give you the simplest fraction. So for example, if I use that method on this, 5/8 plus 7/12, if I use this new method of cross multiplying the numerators and multiplying the denominators, well 8 times 12 is 96. And then we cross multiply the numerators, so 5 times 12 is 60, plus 7 times 8 is equal to 56. And then that gives us, well, 116 at the top over 96. But now we have to sort of simplify this. So we can divide top and bottom by 2, and that gives us 58 over 48. And we still have to divide by 2. So we now get 29 over 24, and we've now simplified as much as we can. Whereas if we use the previous method, so if we do question 3 again, 5/8 plus 7/12, and the previous method was to find a common multiple of 8 and 12. Well, 8 and 12 both go into 24, so we could do them both over 24. That's the lowest common multiple. Then what did we multiply 8 by to get to 24? We multiplied by 3, so we also have to multiply the 5 by 3 to get 15. What do we multiply the 12 by to get to 24? Well, we multiplied it by 2, and therefore we have to times the top by 2 as well. And 7 times 2 is 14. And now we've got a common denominator, so we can add the numerators, and we get 29 over 24. Now we get the same answer as before, but do you notice in this case I didn't have to subsequently simplify the fraction? Right, let's do a subtraction now. So we've got half minus a third. And it's exactly the same method as before, except for we subtract the numerators at the end rather than add them. Now, if we try and do the quick way, we can multiply the denominators. So we get 6, and then we cross multiply again, but make sure that that 1 gets multiplied by the 3, so you get 3 minus, and that 1 gets multiplied by 2. So 3 minus 2 would be 1 over 6. So it doesn't matter in which order you subtract these. That 1 gets multiplied by the 3, and then you're minusing, and then that 1 gets multiplied by the 2 to get that. What about the next one? Now we've got some mixed numbers in there. So 3 1/3 plus 3/4. What we could do is we could convert that to an improper fraction first. So to convert that to improper fraction, we do 3 times 3 is 9, plus 1 is 10. So it's 10 over, and we use the same denominator, plus 3/4. So we do the same thing as before. Let's do it the quick way. 3 times 4 is 12, so we use that as a denominator. The 10 gets multiplied by 4, which is 40, plus, and that 3 gets multiplied by 3, which is 9, so we get 49 over 12. And we could always convert that back to a mixed number. In this case, well, 12 goes into 49 4 times, and then we have a remainder of 1, so it'll be 1 over 12. What about the next one? Now we've got 11 4/5 plus 78 1/2. Now, it'd be really cumbersome if we had to convert these to improper fractions and then add them, because the numerators are going to be absolutely huge. If we do 11 times 5 plus 4, we've got 59, and 78 times 2 plus 1 is also going to be a big number. So is there a way that we can avoid having to convert them to improper fractions? And there is. And what we do is we basically just add the whole parts, and we add the fractional parts, and then we might have to do some adjustment at the end. So 11 plus 78 is equal to 89. And then we got to do 4/5 plus 1/2. So let's do that over here. 4/5 plus 1/2. If we do it the quick way, 5 times 2 is 10. And then let's try and do the numerator in our head. 4 times 2 is 8, plus 1 times 5 is 5. 8 plus 5 is 13. So we've got 13 over 10. So we've got 89 and 13/10. Now, we know that the fractional part of a mixed number has to be a proper fraction, and that's not. We can see the numerator is bigger than the denominator. So that mixed number just looks odd, doesn't it? But what we can do is we can fix it, because we can see that is 1 and 3/10. So we've got that extra 1, so that 89 goes up to 90, and we've got 3/10. So what we can do is we can subtract 1 from this, and therefore to compensate add 1 to this. So when we subtract 1 from this, we're getting rid of 10/10, that's the same as 1 whole, and when we get rid of 10/10, that 13 goes down to 3. Let me just do one more quick one like that. If we had 103 and 2/3, and we added 204 and 3/4, well, we add the whole parts first, so that would be 307. And then let's add the fractional parts separately, so 2/3 plus 3/4. Well, 3 times 4 is 12. 2 times 4 is 8, plus 3 times 3 is 9. 8 plus 9 is equal to 17. So it's 17 over 12. So we've got 317 and 17/12. We can subtract 12/12 from this, i.e. a whole, so it becomes just 5/12. If I subtracted 1 from this, I need to add 1 to this to compensate, so it'd be 308. So you can see that kind of overflows into the next hole, so we get an additional hole. What about subtraction? So I've got 7.5 minus 1 3/4. Now this one, the numbers are sufficiently small that I could, if I want, convert these to improper fractions first. So 7.5 is 15/2. Minus 1 3/4 is 7/4, and we do our usual stuff. We could just multiply top and bottom by 2 there, so it's 30/4 minus 7/4. We've got the same denominator, so that is 23/4. Now the last one we're not going to be able to do that with, so we've got 86.25 minus 27 3/5. Now when we get huge numbers, we try and convert these to improper fractions. Now we might wonder if we do a similar thing to before. Well, it's quite difficult because even though 86 minus 27, if I subtract the whole parts, that's easy enough. It's harder to subtract the fractional parts because 1/4 minus 3/5, you would end up with a negative number because 3/5 is bigger than 1/4. So what you need to do is you need to make sure that that fraction is bigger than that one, so you've got an easier subtraction. And the way you do that is the opposite to before. Remember when it kind of overflowed, we got rid of 12/12 and then therefore added 1 to this. We can do the opposite. We can sacrifice a whole, so we reduce it by 1 whole. But if we sacrifice a whole, how many extra quarters do we get? Well, a whole is 4/4, so we get an extra 4/4. It will now be 5/4. So if you remember like column subtraction, do you remember that you could sort of borrow from the next digit to the left? It's exactly the same process here. I'm borrowing a whole to get myself extra quarters. And now it's a bit easier because I can do 5/4 minus 3/5 separately. We can do the quick way. 4 times 5 is 20. 5 times 5 is 25. Minus 3 times 4 is 12, 25 minus 12 is 13, so I have 13/20. So this here becomes, well, 85 minus 27 is 58, and then we worked out the fractional part subtracted were 13/20, and we've got our final answer. Let's just do one more of those. If we had, say, 100.5 minus 50 4/5, well, we can't do the half minus 4/5 because 4/5 is bigger than a half. We would end up with a negative number. So we sacrifice a whole, so that 100 gets reduced to 99. But by borrowing a whole, we get an extra whole here. That's 2 halves. The whole is 2 halves. So we now have 3 halves minus 50 4/5. So we do the fractional part subtracted. So 3 halves minus 4/5. If we try and do it in our head, 2 times 5 is 10. Cross multiply the numerators. So 3 gets multiplied by 5, that's 15, minus the 4 gets times by 2 is 8. 15 minus 8 is 7, so it's 7/10. Now 99 minus 50 is 49. And 3 halves minus 4/5 we worked out was 7/10. So we get 49 7/10.